Okay, we're going to look at the next trigonometry question here. And here it is. I think they want us to find cosine theta here. But they've given us 2y on this side, 2y on this side. Hey, that's a nice isosceles triangle. And the side opposite r is y. Well, you have to know that if you want to, this is all set up to use the cos rule. And if you want to find the cosine of an angle, you use it when you've got an angle and two sides on either side, and it can equal this side squared here. It's kind of like Pythagoras. You go this squared plus this squared, a squared plus b squared. But you go minus 2 times a times b times the cosine of the angle in between. That's what y squared is, what pq squared is. In fact, let's look at the memo here. All they do is pq squared equals qr squared plus pr squared. So you just use the law of cosines. pq squared equals this squared, qr squared, pq squared minus 2 times them multiplied together times the cosine of the angle in between. Well, that's your first step. But qr is 2y, pr is 2y, pq is y. So there's an equation. Instead of pq, you put 2y, pr 2y. Now multiply it out, you get 4y squared, 4y squared. This here is, that's what you would get. You subtract y squared, you move this to the other side, and then you divide by 2 times 2y times 2y. 2 times 2 times 2, that's how you got 8y there. Y times y is y squared. Hey, on the top, you've got 7y squared. The y squareds cancel. The cosine must be the ratio 7 over 8. The cosine of theta must be 7 over 8. Now the next question says, determine PT in terms of y. If P hits right at the circumference at T, how could you figure out PT? Well, the big secret is PTR. That angle there is 90 degrees because of angles on a semicircle. And if it's 90 degrees, we can use SOHCAHTOA. The sine of theta is PT over 2y. Well, in fact, that's your answer. The sine of theta is PT over 2y. You multiply it by 2y, so PT equals 2y times sine theta, and you write angle in a semicircle. And there you go for that 2D trig question.